Number 1. In the example problem, 2.4 times 10 to the 6th was rewritten as 24 times 10 to the 5th. Explain why those expressions are equivalent. So, in 2.4 times 10 to the 6th, they moved the decimal back one place. I always told you to take the smaller exponent and move the decimal up. They did the opposite, and they turned that 6 into a 5 by moving the decimal back. They moved the decimal back to make the exponents the same. Number 2, James rewrote the problem as 0.38 times 10 to the 6th plus 2.4 times 10 to the 6th, then added. Does his method work? Explain. Yes, this is the second method that I told you about. He moved the decimal up one space to make the exponents the same. Number 3, you can use the same method to subtract numbers in scientific notation. Complete the steps to evaluate the subtraction expression. 2.1 times 10 to the 9th minus 9.7 times 10 to the 7th. In this first part, I can see that they want my exponents to be a 7, so I have to move the decimal back 2 places. And I get 210. I'm going to subtract my numbers, 210 minus 9.7. And I get 200.3 times 10 to the 7th. I move the decimal up 2 places and get 2.003 times 10 to the 9th power. Number 4, evaluate the expressions. 4.6 times 10 to the 9th plus 1.7 times 10 to the 7th. I always told you to keep the larger exponent, move the decimal up 2 places to turn that 7 to a 9. I'm going to add 4.6 plus 0.017. I get 4.617 times 10 to the 9th power. Same thing when I subtract. I want to make the exponents the same, so I keep the larger one. I'm going to keep the 5. I'm going to move the decimal up 1 place. I'm going to add 5.4 minus, I'm going to subtract minus 0.14. I get 5.26 times 10 to the 5th. Number 6, explain one way that you could check your answer to problem 4B. I could add 5.26 times 10 to the 5th plus 0.14 times 10 to the 5th, and I should get 5.4 times 10 to the 5th. Number 6, find the perimeter of the rectangle in scientific notation. Perimeter means I'm going to add up all the sides. So this side down here is 2.4 times 10 to the 3rd, and this side over here is 8.2 times 10 to the 2nd. I'm going to add all those numbers, but the exponents have to be the same. So I keep the larger one, I'm going to keep the 3's. I'm going to change these 2's into 3's by moving the decimal up 1 place. So I'm going to add the 2.4's and the 0.82's. So 2.4 plus 2.4 plus 0.82 plus 0.82 gives me 6.44 times 10 to the 3rd power. Number 7, the area of the Southern Ocean is about 7.85 times 10 to the 6th square miles. The difference between the areas of the Indian Ocean and the Southern Ocean is about 1.865 times 10 to the 7th square miles. Explain how to find the area of the Indian Ocean. So it tells me that the difference between the areas of the Indian and the Southern is 1.865 times 10 to the 7th. It gives me the difference. So I have to work backwards. I'm going to add 7.85 times 10 to the 6th plus 1.865 times 10 to the 7th. It gives you the difference. So you add the numbers to find the area. It then says find the area. So I'm going to go ahead and add them. The exponents need to be the same, so to change that 6 into a 7, I move the decimal up one place. I'm going to add 1.865 plus 0.785. I get 2.65 times 10 to the 7th power.